The UK's power grid is getting what might be one of the biggest digital upgrades in its entire history. It's a huge project called EnergyOS, and today we're going to break down exactly what it is and, more importantly, why it matters so much.
So, look, the UK is racing towards a future powered by clean energy, which sounds amazing, right? But here's the big question, the one we really need to think about. What if the digital systems running that future just aren't up to the job? What if this whole incredible vision is being built on a foundation of digital sand?
And let's be clear, this is absolutely a sprint. The UK has set this incredibly ambitious goal for 2030, and honestly, the clock is ticking.
That goal? It's called Clean Power 2030, and the scale is just staggering. We are talking about building enough new wind and solar to generate as much electricity as the entire country uses in a year. That means a once-in-a-generation build-out of new infrastructure, and it has to happen fast.
But you know what? The biggest roadblock isn't necessarily pouring concrete or putting up wind turbines. Nope. The real, kind of hidden obstacle to this clean energy future, it's digital.
And this really breaks down the problem. Our ability to deliver clean power is hitting a wall for three big reasons. First, you've got fragmented sources of truth. Basically, everyone has their own version of the data, and nothing quite lines up. It's a mess. Second, the control loops are way too slow. The grid operates in seconds, but the decisions behind it can take months. And finally, the incentives are all wrong. The market might actually reward a power plant for generating electricity we don't even need, just because the rules are outdated. You can see how that's a recipe for waste and risk.
So, what's the solution to this digital chaos? Well, it's an idea called EnergyOS. And the best way to think about it is like creating a kind of internet for energy. A shared digital operating system to get everyone and everything on the same page.
So what is EnergyOS really? Well, the official definition is a national interoperable digital operating system for energy. And that word right there, interoperable, that is the absolute key. It's all about making sure the hundreds of different companies and systems involved can finally talk to each other seamlessly. And this quote just nails the core concept. This is not about building one giant monopolistic platform to rule them all. No way. Instead, think about how the internet actually works. There isn't one single company that is the internet, right? There's a shared set of rules, protocols, that let anyone connect, communicate, and innovate on top of it. That's the exact model for EnergyOS.
So, just to be crystal clear on what this is and what it isn't. It is a set of shared rules, a system for trusting identities, and a way to coordinate actions. It is not a new monopoly platform. It's not a perfect digital copy of every wire and pole, and you're not going to download an EnergyOS app on your phone. Although, the cool new apps you will use will be built on its rules.
Okay, so we've covered the what. Now let's dive into the how. Let's take a look at how this whole system is actually designed to work. What are the rules of the road?
The entire system is built on these 6 core principles, but I want to highlight a couple. Consumer first by design means your electric car isn't just a drain on power, it's seen as a valuable asset to the grid, and you get clear financial benefits and protections. And local where possible, national where necessary, well, that's just common sense. It means trying to solve a power issue in a single neighborhood first, which is way faster and cheaper than getting the entire national grid involved.
Okay, so how on earth do you build something this massive and complex? Well, the whole thing is designed as a stack of layers, just like that internet protocol we were talking about. Each layer has a very specific job, and they all build on top of each other to create the whole system. Let's walk through it, from the ground up.
So, at the very bottom, layer 1, you've got the physical world. This is everything you can actually see and touch. The wires, the wind turbines, the solar panels, and yeah, even your EV charger at home. Everything else we're about to talk about is digital, but it all has to sit on top of this real-world physical foundation.
All right, moving up. Layer 2 is telemetry and control. Think of this as the grid's nervous system. It is all about secure communication. How does the grid tell a wind farm to slow down or talk to a giant battery? More importantly, how does it know that the device it's talking to is the real deal and not some hacker trying to get in? This layer handles all of that critical, secure messaging. Layer 3 is, and I can't stress this enough, absolutely crucial. This is the common language layer, the universal translator for energy. Right now, one company might define a power outage completely differently than another. This layer fixes that. It creates a standard digital dictionary, defining what a kilowatt is, what an asset is, so that when two systems talk, they mean the exact same thing. No more fragmentation. On top of that common language, you build layer 4, market and policy.
This is where all the economic and regulatory rules of the game live. Remember those misaligned incentives we talked about earlier? This layer is designed to fix them. It's where stuff like electricity prices and carbon incentives get coded directly into the system, making sure the market rewards actions that actually help keep the grid stable and green.
Now we get to Layer 5, orchestration and optimization. This is the brain of the whole operation. It is constantly looking at all the data from the layers below it: weather forecasts, energy prices, how much power homes and businesses are using. And then it uses all that info to make incredibly smart decisions, like when to store extra wind power in batteries, or when to ask a bunch of EVs to pause charging for a few minutes to prevent an outage. It's the conductor of the entire energy orchestra.
And finally, right at the very top, we have Layer 6, the experience layer. After all that complex tech humming away in the background, this is the part we will actually see and use. This is where developers can build new apps for our phones to help us save money, where businesses can get web portals to manage their energy use, and where grid operators get the futuristic tools they need to keep the lights on for all of us.
So after all that tech talk and all those layers, what's the actual payoff? Why does building this complicated digital stack even matter in the real world? Well, let's look at the benefits of getting this right. You know, if we pull this off, success by 2030 looks pretty amazing. New wind and solar farms could connect to the grid in months, not years. You, as a regular person, could easily and fairly get paid for letting the grid borrow your EV battery for a bit during peak hours. And the big one, all this efficiency and coordination leads to real, tangible savings on our energy bills, plus a much more secure and resilient grid for everyone.
Look, at the end of the day, the UK's clean energy system is coming one way or another. The real choice we have is this. Are we going to build a system that's smart, fair, and resilient, or are we going to stick with the old way and end up with one that's slow, fragmented, and a whole lot more expensive for every single one of us? That's really the question EnergyOS is forcing us to answer.